Good morning, sir and classmate.
Good morning, all. Hey guys, good morning.
Yes, good morning, sir.
How are you all doing this morning? Want to talk to me?
Good so far, sir.
Nice. I just doing good. One to you, Andrew, and following it and test.
Morning, sir.
And I'm morning.
I'll wake up, you know.
You still awake for? Yeah, man. You know, I'm feeling led to share something with you this morning. I'm just feeling so led to share something with you this morning. So yesterday, I went on the road briefly. You know, I oversee a senior citizen from a church. So it has been a really rough past couple of weeks. And I said, you know what, let me go. And she's blind. I said, let me just go and just read her text messages that come in and, you know, do what it is that I normally do. And her helper went home for the weekend. So she was there alone. And I was leaving her house to go back to my house. Caught up in the line of traffic. And the next thing I hear is boom, somebody ran right into the back of my car. And of course, I had my family with me, so I immediately turned around and, you know, from I make that quick turn around, I started feeling some neck pain and back pain. So I ran into somebody because of the impact that I got. But, you know, I was stationary, so when, you know, my foot was on the brake, of course. So when I got the impact, my initial reaction was to increase the pressure on the brake. So the person in front of me didn't get such a great damage. Long and short, it was a church brother, is a church brother of mine that I ran into.
Oh my.
And you know, on the way home, the young man said that boy, I shut the car shut off. I said, well, if the car is shut off, the car would not move at that speed. It would have stalled. Anyhow, on the way home, I went to the police station, but while I was giving the report, it was the pain sort of got, you know, very intense. I went to a private doctor and I said, you know what, it sounds like you have to run X-ray. No, let me tell you, say, I don't know if it's COVID or what, but I spent a good 5 hours. Well, we spent a good 5 hours last night at the hospital to go and do some tests, and was a couple hundred of thousands of dollars later. But you know, I'm just giving thanks. That's the point I'm making. I'm giving thanks that I'm alive. It could have been so much worse this morning, you guys. Would have been here waiting for class and hear that something terrible happened to your lecturer. And you know, I got up. I mean, I still having some. I mean, of course, the muscles got bruised. I'm still having some neck pain mainly. And I mean, the impact was so great. I wear glasses, and my glasses flew off my face and went under the gas pedal. When I was ready to drive, and I was like, "Where's my glasses?" And fortunately, I didn't press on the accelerator because it would have crushed the glasses. You know, I came home last night. I mean, I was starving, Jesus, and you know, of course, you can't be starving and go to Pizza Hut and KFC's the worst combination with all them grease, but that's what I was feeling for. And came home, get a bite, then go bed and then go lay down. And I got up about 2 o'clock this morning. Never went back to bed until about after 4 minutes to 5. And then I just reflecting. I'm not lying. I just started to reflect and I said, you know what? It could have been worse. I could have been a statistic this morning, and for something that you know I was, you know, innocent to. And then I started going through TikTok, and I recognized that a little young lady who, I mean, you know, she tried her little stuff. Lexi, I hear she died in a same, you know, motor vehicle accident. And then in the early o'clock this morning, I started feeling very depressed. And I'm saying to myself, you know, just look at that. I walked out all right. She didn't walk out at all. But I'm hearing conflicting stories. Some of them say she didn't die, but I saw a Gleaner report to say that it was confirmed that she died. And you know, it's just one of those things that you know you just have to reflect on. I'm just going to ask you that just be careful. I mean, I was this person who hit me actually broke the light. I was ahead of him. I saw him breaking the light, and I saw him, you know, coming behind me. Never had any indication that he was going to do that. I think what happened is that when he was going to stop, I quite frankly believe that he touched the accelerator instead of the car shutting down. But just be safe, guys. I beg of you, don't follow this narrative about COVID now keep and on not wearing a mask and the country open up. Just be mindful that in the UK, is some hundreds of thousands of people got reinfected with COVID. In the United States alone, it's 3,000 plus people got reinfected. In China alone, right? So I know Jamaicans travel US, UK, China, and them places. So school open up fully and everything open up fully. Pfizer come out with a fourth booster. You know, people have been putting so many of these things in their bodies. You know, you put it in only for 1 time or 2 times and say that is it. No matter if we take booster now, and you know, it never ends. And then Putin a war, Ukraine, and Putin war, China for come help him war, and USA, any China could do that to go happen. And anyhow that happens is going to be another world war. And another world war, we're not have enough food because the whole supply chain have mash up, the investment have go down, and it never ends. It never ends. I beg of you, my students. We may not have met face to face yet. One of these Saturday mornings when the sleep come out of Andrew hand, and you know, I'm ready. We're going to have a grand reveal online, and we just, you know, do it till every now and again we turn our cameras on. I know some people use data and it eats up your data. Last night, fortunately, I was teaching last night, but fortunately I have a student teacher, and she was supposed to be on for an hour. And when I sent her the link and told her what happened, she said, "Sir, go on to the doctor." I said, "Yeah, man, I'm on my way there." So I couldn't teach last night. I just listened in. So I don't even know what my data on my phone looks like, but I was just listening in, you know, on the class, making sure that things are really supposed to be. So I'm only sharing this, you know, really not to be pitied, but to say to you, if you're late, you're done late already. I better you catch the late than don't catch there at all. Just be very careful. It may not be a motor vehicle accident. It may mean that you're not vigilant in doing something else. Just be careful, guys. You know, imagine COVID never take you out, and this young man didn't want to come take you out yesterday. So I'm just giving thanks. Anyhow, enough of my sad story.
Well, sir, we're happy that you're alive, sir. That is good.
All the time, all the time. Thank you, Andrew. Thank you, man. All the time. You know, Satan and his kingdom, very upset at this point in time. Very upset at this point in time because he thought that yes, I'm going to get that sucker today. Get home, right? So heaven is rejoicing. Satan and his kingdom, you know, very sad, and they will remain sad. I'll be around for quite a while. So will you all. All right, I'm not seeing any new students. Yes, I'm seeing one. Miss Sash, good morning. Welcome to this part of your sojourn.
Morning, sir.
How you doing? All right. So we are 8 strong. I know there's supposed to be another student who's supposed to be joining. But let us see what will happen as we still continue to give prerequisite overrides. All right. How many of you were able to do those 2 questions? And if you did, what answers you got for the first one and the second one?
first one, I got 6.
The second one is what?
Second one, I got 6/4. I'm not sure if I should have leave it there or
You got what over 4 Tess?
6/4.
Okay. Okay. Anybody else? Dwayne, Andrew.
Yeah, I brought down the 6/4 and get 3/2.
Very good. Very good. Diana, what you get?
Me answer, yes, sir.
Oh, sorry. Laura Lee, what you get? Thank you, honey.
Yes, sir. I got 6 for the first one. But when I looked over, I realized that it is saying the limit as x tends to negative infinity. So then if it's the same way, you would work it as normal.
Okay. Can somebody answer Laura for me? Would it be the same way? What Sir said to you last week? Are the same way, man. Negative infinity, positive infinity. One of them just go up on the to the left side of the number line, and the other one will go to the right side of the number line. You follow me?
Yes, sir.
Yeah, man. So if it goes to the left side of the number line, it will move to infinity, but positive infinity. If it goes to the left side of the number line now, it is moving to negative infinity, but it's still on the x-axis. So what obtains the positive infinity, the same thing that obtains the negative infinity. So you are going to get the indeterminate form. Now, it is important that you state your indeterminate form. All right. So see the solutions to my question. Here, oh gosh, here is going to be indeterminate. But sir, if a negative infinity, how you have positive infinity or positive infinity? Can somebody explain that to me, please? Why do I have positive infinity over positive infinity as opposed to negative infinity over negative infinity? I could have negative infinity over negative infinity now, because negative infinity over negative infinity is also indeterminate. But why in this particular case? Aha! Why in this case I have negative infinity over negative infinity, and up here so I have positive infinity over positive infinity. All right, let me go back to the other share, and you tell teacher why. Sorry, why for the first one I have positive infinity over positive infinity, and in the second one I have negative infinity over negative infinity. It's not a trick question, I just want to make sure that you understand it. Háblame. Say something. You can is that a right or wrong? And it's better for you to be wrong here than on the exam. But here, I ask a question and nobody answer me. Come on, guys, talk to me now. I'm asking, why do you think I have positive infinity or positive infinity here for the indeterminate form, and down here I have negative infinity for negative? You look at the function, no man, I spoke about it last class.
So both of them are negative infinity.
No, I'm saying to you that the first one is positive infinity over positive infinity, and I'm telling you that the second one is negative infinity over negative infinity. We want you to tell me why I have one to the positive infinity. Both of them, how I have it is correct, you know. The first one is negative, is positive infinity over the positive infinity. Second one is negative infinity over negative infinity. So I'm saying to you, why did I get that as my answer? I want you to look at the question and tell me why. I told you last week. Talk to me, please. Don't just sit there. Habla me. Okay, all right. Dwayne, unmute and talk to teacher. Tell teacher what you're thinking. Since you're not talking, let me talk.
I sorry, I drop off my chair. Honestly, I don't remember why, sir. Honestly, I'm trying to remember.
Look at the functions. I give you 2 more minutes, and I'm gonna go to Andrehan. Andrehan, what do you say?
I remember you saying something, but I'm here trying to jog my memory.
Not clicking.
Coming to memory at all.
All right, Damian, what do you say?
Sir, I'm here trying to remember as well.
I need to pick up my math then.
Listen to me. No, go buy me some memory tablet then, you know. Test. What teacher said last class? Tell me.
I think I already need that memory pill because I don't
All right.
remember.
Okay, so let me ask you. You know, one of the things that I don't like about our system or it sets up is that I'm unable, for the most part, to do some sort of, you know, mathematical investigations. I don't want to just come and tell you, because when I come and tell you, it does not train your brain to think on your own. And that's why you have someone that's called a supervisor. And one of the things as a leader, I don't micromanage, because people must grow. People must make decisions. And if the decisions are not good, they must stand up by the decision they have taken. Now, if I am supervising all of you, and at some point in time, each of you makes an error, you will have to tell me why it is that you made such a decision. Now, if the decision at that point in time that you took is plausible, but an incorrect one, I don't have a problem, because it says to me that you're thinking. And this is how you train people. This is how you set up your business in such a way that you can say, all right, the plan, you know, so we can go on a 1-week vacation because my staff is competent. I know how it is that them can think. But if you are over them every minute, it means you have to go there. It means when you want a vacation, you have to go lock down the company because they don't know things on their own. This is what I'm talking about here in the classroom. When you're in the exam, and remember again, your exam is going to be face to face. When you're in the exam, I am not going to be there. The most you can do for me or I for you is you hearing my voice. I don't know if it happens to you, but when I was in the school, I could hear my math teacher saying some things in class. I said, okay, yes, that is it. But I want you to think. So let me ask you a question, and this is an exercise for all of you. I want you to evaluate, okay, write down for me x to the third power and x to the second power. X to the third power and x to the second power. And in the first example, we have x to the second power and x to the third power, I'm sorry. I'm going to ask you to substitute 1. Matter of fact, substitute -1 in both of them for me and tell me what answer you get. Substitute -1 in both of them. -1 raised to the third power, tell me the answer. -1 raised to the second power, and also tell me your answer.
Sir, -1 to the how much was, sir?
To the second power and to the third power.
Why would give you a negative answer? I want to give you a positive.
Which one give you the negative answer?
X to the third.
X to the third give you the negative answer, and x to the second give you the positive answer.
Yes, sir.
Okay. Does everyone agree with Dwayne?
Yes, sir, that's what I got as well.
That's what they got as well. Who was that? That was Tess or Laura?
Yes, sir.
Tess. All right. We have to go find out how we know how to differentiate the tone of voice, because tone is on like over the phone. I mean, my earpiece. All right. So, all right. Sash, Norman, when I come to the class, I must say good morning here. Damien, Colin, maybe at work and can't speak.
Yes, sir, I'm at work, but I can talk.
Oh, supervisor, not reach yet. All right, go and talk to teacher.
No, sir, they gave me one of the earphones that I can use on the computer.
Well, you swag buck up now. Very nice. Good morning, Mr. Webster.
Good morning, sir.
You're not allowed to be in bed. Right? You're not allowed to be in bed. All right? All right. So I'm really very happy that you were able to see that. Now, do me a favor. Do me a favor. Dwayne says to me that, and I'm going to repeat it for emphasis. Dwayne says to me that the one that is raised to the third power is negative, and the one that is raised to the second power is positive. All right. Just hold that in your head. Hold that. Don't go nowhere with it. Just hold on to that. Look back at my first example. Look back at my second example. I am saying to you that the first example went to positive infinity, but the second example went to negative infinity. Look at it and tell me if you agree now. And if yes, tell me why. If no, tell me why.
Well, could it be, sir, based on the power itself, the highest power that it is raised to, whether it is negative, whether it is odd or even? If it is odd, then it's negative, and it's even, it's positive.
That's what I said to you last class. Very, very, very good. So you see what I'm saying? I could have come back to class the way and say, no man, when you raise a negative power, a negative number to an odd power, the answer is negative, and when you raise a negative number to an even power, the answer is positive. Anybody remember me saying that now?
That's how the memory goes, sir. It needs jogging.
Yeah, but you remember when I said that no, when I said to you that when you raise a negative number to an odd power, it's negative, and when you raise a negative number to an even power, it's going to be positive, right? And that's what has happened here. So when you look at your limit, you recognize that the highest power here is to the fourth in both numerator and denominator. So irrespective of what negative infinity value you place inside of this number is always going to be positive. The number you're going to be negative, so is this one. Because this x is raised to the first power. 1 is an odd number. So when you have this x be negative and you multiply by a negative number, this term becomes positive to be added to this positive term, but this term becomes negative. But this is the highest power, so it supersedes everything, and because it is to the fourth power, it makes the value in the numerator here positive. The highest power is 4, it makes the value in the denominator positive. So I'm going to have positive infinity for positive infinity. I don't know why the Spirit of the Lord asked me to just zoom in on this morning. This wasn't one of the plans for me to zoom in. This could be a possible multiple choice question. It is a possible multiple choice question. All right, and you have to be able to look at it. Now let me just jump down to this one here. This one here, the highest power in the numerator is x to the 7th, and the highest power is also x to the 7th in the denominator. But it is 7. 7 is odd, and I'm raising a negative number to an odd power. It's going to be negative. So that's why I have a negative infinity there. A negative infinity. So just always be mindful of what it is that you need to look out for. It's very important that we do just that. And as I said before, there are some little things that I'll be telling you about, and I can't write down everything. I'll write down as much as I can, but I can't write down everything, which is why it's very good that you come to class and listen to what Sir says. One quick thing I'm going to say to you. I remember when I went back to the university to study, I was in a course that was totally out of my scope. I was always a science student, and I decided to switch and do something for my second degree, and went into the class. I don't think I had much interest in the class. I think I had much interest in the lecture. A senior person, big woman, but she just dressed nice and carried herself well and well spoken, and I was just very impressed by her. And I'm saying to myself, I wonder if when I get to her age, I'll be as eloquent and knowledgeable, and there's no question and answer that she fumbles on. And she just came to the class, to the lecture room, with a wealth of knowledge. I mean, I just was intrigued by just listening to her. And sometimes she will just say some stuff, and I say, but that makes sense. And I just take my pencil. I always have colored ink and a pencil. And I just scribble, and I don't write necessarily on my lines in my book. Sometimes I write cross me because I'm listening to what she said. She don't give notes, but I'm listening to what she's saying, and and I just scribble it. And then I will learn from that. And I mean, the amount of information that I get just from her saying some things in class. What Sir said to you is, when I come to class and say, when you raise a negative number to an even power, the result is always positive. Write it down. Write it down, because it's very important. It's very critical. That will take you in not only for business calculus, but business statistics and operations research. All right. And when Sir says to you that when you raise a negative number to an even power, the answer is positive. When you raise it to an odd power, the answer is negative. Write it down. And I will say many other things. And I won't necessarily say to you, oh, this is important, write it down. But if it's so like it makes sense, write it down. It will come back to you. All right. So now that I have explained it, I'm very happy for you guys. I don't need to go through here because you guys know how. By the way, let me just check on something here. Were you able to spot this answer even before you work it out? To get, let me just change something here. Not really change, sorry. Change is not the correct term that I want to use. Because, right, so change is not what I wanted to say, so forgive me. Let me ask you, were you able to to look at this by inspection and recognize that the limit would have tended to 6/4? Anybody remember how we did that last week? Want to talk to me now?
Yes,
Yes,
sir.
sir.
Mhm. All right. Let me just remind you of something. You see, for example, I'm morning like this morning. You see, especially when I'm holding my head to look at the computer and feeling the next day, I could have sent a message to the class that I'm not feeling well. I will call it off, but I know that this is a 60-hour course. I know that I will have a call in maybe on a Sunday afternoon for my Sabbath in order to make up some sessions. So I know if I give up these 4 hours, it's going to come back to bite me. I want them to talk to me. Please. I don't want to be having to repeat myself. When I understand it, want to talk to me. Last week we had a good enough class. Please just be proactive, engaging in the participatory in the whole learning process. Please, I beg of you, just talk to me. Talk to me. I mean, I get your energy from it. I don't want to have to fall asleep. Around the computer at early morning, and Andrew Han, I don't want Andrew Han fall asleep. I don't want Andrew, not Andrew. Web stuff, we're gonna drop asleep. All right. So please, talk to me. All right, let's go again now. And you all remember, just by looking at this, no, that's not the one I want to talk about. 6/4. Hold on. Oh, is this a mistake here, so? You know what I said about the 6/4? It's not supposed to be 6/4, it's supposed to be 6/1. Do you remember how to look at this and recognize that your limit is going to be 6/1, which is equal to 6? By looking at the highest power. All right. Now we're going to deliberate that. That was just a review of what it is that we did. I will come back to that for another thing. This is important. The limit of a constant is a constant itself. You'll hear me say this many times over. The limit of a constant is a constant itself. The limit of a constant is the constant itself. I will go through this example, but I don't want to spend any more time doing any more limits of this nature. So I'll maybe give you this as a warm-up question for next class. But what I want you to remember is this thing here, very important. Let me see if I can colorize it. The limit of a constant is a constant itself. Important. One of the most important things when you do the limits of a function, and especially, hopefully I can get here today, especially when I'm going to be doing differentiation from first principles. You will hear me say this very often. The limit of a constant is a constant itself. The limit of a constant is a constant itself. The limit of a constant is a constant itself. So what do you mean by that? When we find the limit of a constant, so what is a constant? A constant is a number that stands alone without a variable. Like 4x, sir? No, 4x is not a constant because you have a variable beside it. Oh, like 4, because there's no constant to it. So a constant is something that is written down without a variable. If I'm finding the limit of 4, what is the limit as x tends to infinity of 4? 4. But the x tends to infinity, so it must be 4. 4, because I'm finding the limit of a constant. So it does not matter where the function goes to. The function can go to a million, billion, trillion, quadrillion. Once I'm finding the limit of that number of a constant, it is going to be the constant itself. Tell me that you get what I just said a while ago.
Yes, sir.
Yes, sir.
Good job. Ouch. Okay, so I'm finding the limit of a polynomial. Now, polynomial functions are the easiest ones to find the limit of. The easiest ones to find the limit for. Normally, when you go into the exam and they give you a function to find the limit of this polynomial, they not give more than 2 marks. And if they do give you more than 2 marks, I can bet you, I can guarantee you that it will not be more than 3. I can't recall seeing a question to find the limit of a function and then give 4 marks. Of a polynomial function and then give 4 marks. Most times it's either 1 mark or a 2 mark. And I'm being very real with you. All right? So it's very easy. Now, when you find the limit of a, and I did ask this question last class, what was in my mind? When you find the limit of a function, when you find the limit of a function that is a polynomial, what do you mean by polynomial, sir? You know, have the numerator and a denominator. It's only the ones that have numerator and denominator we can talk about indeterminate. Only the ones that have numerator denominator we can talk about indeterminate. Oh, that's how you can get the 0 over 0, sir, and the positive infinity over positive infinity. And worst case, sir, we can get negative infinity over negative infinity. Very good. So I must have a rational function in order for me to see that, or to say that I have something that is indeterminate. Okay. What is the significance of that, though, sir? You're just asking for a friend. All right, no problem. The significance is, at some point in time, the function, the rational function, becomes discontinuous. And I want you to hear that word. At some point in time, the function becomes discontinuous. Discontinuous, what does that mean? Let me do this quick example. Take your implement, your writing implement, your pen or your pencil, and I want you to, you know, like when you're testing out a pen and you make some curvy, I want you to do a straight curvy without lifting your implement. Thanks for complying, because I know some of you don't even take up a pencil yet. And then now the rest of you know, I want you to do the same thing, but at some point in time again, lift the pencil and then continue. Lift the pencil and then skip a beat and then continue to do the stuff. Thanks for those who did it. What am I talking about, you know? Is it the one where you draw the continuous wavy line without lifting? That function is going to be determined as being continuous. I made a continuous swirly, curvy. The other one is going to be discontinuous because at some point in time there was a break. All right, let me give you a real life example. You know I have 4 youths in my class. Let me see if I can remember them name without looking. I have 2 Ds, 1 A, 1 N. Norman, Dwayne, there's another D, and Andrew Hanna. Who's the other D? I'm not looking back. Oh crap, I have to look back. I'm cheating. Damian, right. Now, some of the females in the class may say, sir, the Jamaica man, them what list? Them what is them, what is them, what is them, what list? And my 4 youths in my class may say, no. Dress up yourself. Dress up yourself. I'm a good father. I'm a good husband. I'm a good provider. Right? Now, why am I saying this? Because the person who may say that the Jamaican man them what list may have experienced the woman may have experienced the husband who went out and have another family. That is discontinuous because he was not consistent in staying inside of his household. That's an example. That's a practical example of a family that is discontinuous. Another example is you may be studying every week, but 1 week you decide to say no study. That is discontinuous. All right. So the only time you can find a function that is discontinuous is when you have a rational function. So rational, we mean again a fractional function, because at some point in time that denominator is going to go to 0, and when the denominator goes to 0, it becomes inconsistent, discontinuous. All right. Then sir, you have to write down all the way. Say, I am speaking it now. You will now see it. I'm speaking it now. You will now see it. All right. So for the polynomial function, because I don't have a fraction, it means that that function will always be continuous. That function will always be continuous. Every single time continuous, because at no point in time can that function become indeterminate, because I can always factor it out. I mean, Evaluate it. How do you evaluate the limit of a polynomial function, sir? By simply substituting. Can't miss it. Let us go. Let me spotlight and show you what I'm talking about. The limit has x tends to -1. Anywhere in the function I see x and put a -1. Remember, when I raise a negative number to an odd power, it becomes negative. So this term now becomes -2. But when I raise a negative number to an even power, it becomes positive. So this becomes +1. So -2 plus 1 is -1. So these give me -1. But watch this. -1 plus 1 is 0. So this cancels out, this, and then now let's say -1 times -3 is +3. All right. So all you're doing is substituting -1 into, the function. All right. Anywhere in the function you see x, you're substituting -1. Just remember, when you're raising a negative number to an odd power, that result is negative. When you're raising a negative number to an even power, the result is positive. Done. A question like this may not give more than a 1 mark. Not even 2 marks. Not even 2 marks. Or, okay, yeah, I'll give you 2 marks. I'll give you 1 mark to correctly substitute the values in here, and 1 mark to correctly evaluate it. All right. So why 1 mark to evaluate it? Because I'll give you the 1 mark to substitute, and the 1 mark to evaluate is to recognize that this negative number raised to the odd power is negative, so you can get the answer here. Do me a favor. Look at this one here. I'm getting -59. Look at this one and tell me if you agree with this. Once you agree, I'm moving into another area now. So I give you 2 minutes to look at it and tell me. Speak to me. I said 2 minutes, guys. Talk to me. I'm gonna like the class today. I'm not lie you. Wanna sound
Yes, sir.
lazy.
Agreed.
Yeah, man. So unmute and tell me to agree, no man. And all right, let's go. All right. So what it is that we're going to be doing today now is to look at something that we call a piecewise function. A piecewise function. Now, this is where I want your undivided attention. So if you're babysitting, and do what a baby to mommy or daddy. If you're lying down, sit up. And if you're half awake, wake up. Don't blink. Don't blink. Let's go. Determinate f of x is continuous. Rockstone. In just the reciprocal continuous and discontinuous. You know why Sir talked to you like that about it? Sir spoke to you about it so that when I'm reading this question now, you can have an idea what I'm talking about. Let me just remind you if it missed you. Continuous means that you have something that is going, and there's no break in it. Discontinuous means that there is a break at some point. You can have one or more breaks. Continuous means there is no break at all. Okay, then how are we going to have a break in this? Oh, f of x is equal to a function. That means I'm talking about a graph. Okay, sir. Oh, that's why I talk about the wave or something, and they say that, you know, okay, yes, sir, I see it now. So that can be a graph. Yes, it can. And it is indeed a graph. So if f of x is continuous at x equals -2, sorry, determine if f of x is continuous at x equals -2 and x equals 2, given that f of x is equal to that, Low, sir. Oh, so you want something look like that. Welcome to big school mathematics. So let me read this now. So this is f of x, but f of x is defined by three functions. F of x is defined by three functions. Now, when you're going to look at school, you know what is look at school? Foundation 1, 2, 3, C-set math and pre-calculus. Now we get into the big leagues of business calculus. I can have one function divided by three equations. The function here and this connect to this, which connects to this. So how you know so them connected? All right, let's just watch it. F of x is equals to 2x minus 1. But it gave me a condition when x is less than negative 2. When x is less than negative 2, or I can say given that x is less than negative 2. Watch the other one. X minus 3, given that x is greater than negative 2, but less than or equals to positive 2. Oh, so the 1 here and the 1 here look alike, sir. We can see the negative 2 and the negative 2, no, sir. Rockstone, see that 2, sir, we can see the positive 2 and the positive 2. That means the function, them connected for real. That's why them ask you x is equals to negative 2 right here, so. And x equals to positive 2 right here, so. That's why you have them negative 2 and positive 2 here, so. Absolutely. And this equation is also connected to this one. It says when x minus 1, given that x is greater than or equals to 2. Okay. So I think I get what it is that you're saying now, sir, that I can have one function that is connected to three equations, and the three equations are indeed connected by these inequalities. Well, sir, I understand exactly what you're saying. But sir, all you read the inequalities answer, so all you get is to be less than. Does anyone have that question in their hearts, in their minds, coming out? Everybody understand how to read those signs?
Yes, sir. Wherever the elbow points, it's where the narrow part is lesser than, and when it's widened, it's greater than.
Okay, all right, I can accept that. I'll give you A+ for that response, yeah. But just to let you know that the inequality can be read from both ways. So just to say to you, you're correct. I mean, I can't take off any marks for that. So what he's saying is x is less than negative 2 because of how I'm reading it, right? But if I was reading it from this way, it would be negative 2 is greater than 2. I mean, x. So he's correct. Where it is closed, which is here, so where the two of them meet is less than. Where they are open, it is greater than. All right. So this one here now is where the challenge comes in. This is x is greater than negative 2, but x is less than or equal to positive 2. When you have a double inequation looking like this, you always work it from the inside out. You always work it from the inside out. So what do you mean by that? You get starting at the middle and work it to the left, start it in the middle and work it to the right. X is greater than negative 2, that is to the left. But x is less than or equals to positive 2. Right? So you're working it from the middle. You're working it from the middle. From the middle to the left, from the middle to the right. From the middle to the left, from the middle to the right. Ah, boy. I am going to be saying something a little later on. Right here, so. No, right up here, so. Comma, please note. But I'm going to just focus on this and say it one more time. So when I get to that point, you can understand what I'm saying or be guided by what I'm saying. X is greater than negative 2 to the left. X is less than or equals to positive 2. I'm going to the right. You notice I never have a negative sign over here, so when you look on the number line, on the left-hand side is negative. Talk truth.
Yes, sir.
And the right-hand side is positive. All right, remember that. On the left-hand side is negative. On the right-hand side is positive. Left-hand side is negative. Right-hand side is positive. So just remember, when we're doing our double not integration, but our double inequality, we read from the inside out. All right, and this one now says x is going to be greater than 2. All right. Now, so at x equals 2, now we start in the question. At x equals negative 2. You see, then answer the negative 2. So you couldn't start at positive 2 first. Is it because negative 2 appears so? We're going to start with that one. You can't start at positive 2, you know. But I like to do my thing systematically. All right. At times, we may have to start with the other one first. And I will show you when that day comes. Yeah, it will come today. When that hour comes. So look at what is happening now. X is equal to negative 2. We started from here. So I now need to look at which of these three functions will deal with x being equal to negative 2. Tell me. Column 1, 2, 3. Is it 1, 2, and 3? Or is it 1 and 3, 2 and 3, 1 and 2? Which one of them three are deal? Which ones deal with negative 2? Talk to me.
Which one deals with negative 2?
1
and 2, sir.
All right, I hear Tessa 1 and 2.
Laura Lisa 1 and 2, sir.
Sure, me no know. Laura Lee or Tess, them sound so much alike. Oh, sure, honey. I'm not looking at my participant list and I use voice recognition. That I'm catching the voice differently. Laura says 1 and 2. Everybody agree with Laura, or somebody wants to say something else? I won't tell Laura if she's right or wrong, you know, but she look at it and say 1 and 2. Which one of these three deals with negative 2? Or which ones deal with negative 2?
1 and 2, I would say.
Okay, why comes?
Because based on if you look in 1, there's x, it mentions negative. X is less than negative 2.
Good.
And for 2, minus 3, and it says negative 2 is less than
X. Nobody remember read inside out. Say x is greater than negative 2.
right.
Right. So what about this one? This one don't talk about negative 2. Say no.
Is greater than or equal to 2.
Positive. Say positive 2. Right. So you're correct. Very good, Laura. Very good. So only these two equations deal with negative 2. Only these two equations deal with negative 2. So at first, when I'm investigating negative 2, I'm going to exclude this one. I'm going to ignore the x minus 1 because the x minus 1 don't come into play yet. Look at it. Look at it this way. You have this here. F of x is money. You have x amount of money to pay 3 bills. My f of x is money. You have x amount of money to pay 3 bills. The 3 bills have different bill dates. Would you pay the bill that is due latest first? Yes or no?
No.
Yes, sir. The one we do first, I think we're going to pay first and get that out of the way. And then we can stretch out the one we're going to pay last and say, no, you know, so we can pay the bill later. Let me see what came down. Let's give me a grace period. And the grace period can fall after payday. Guess what? Only them 2 bills I pay, you know. And then the one I go pay after payday, so I'm just use that on the new pay bill. That's exactly what I did technically. Right? And I'm just showing you some practical ways so that you can relate to the mathematics. All right. We not deal with that one yet. Because the one I'll go come later. The one I'll go come later. Watch me now. So when I speak about the less than sign, where do I go on the number line? To the left or to the right?
To the left.
Very good. Somebody was listening. And when I speak about the greater than sign, where do I go?
To the right.
To the right. And I want you to remember that. Jot that down somewhere. Very important. When I go to the left of the number line, it's When I go to the negative part of the number line, it's to the left. All right, watch me now. X, let me bigify this a little bit more than what it is, so you can see what I'm talking about. X tends to -2, and you notice I have a superscript that is negative. What this reads for me here in Jamaica and internationally, everywhere that you go, it means the limit as X tends to -2 to the left. X tends to -2 to the left. Oh, that's why you have down here for sir. X tends to -2 with a plus. Sir, that means to the right, down. Yeah. So, hold on. My neighbors are smoking. I don't know why them keep lighting bush. Jesus, hold on, please. All right, so I'm back. All right, now, so we're investigating. Remember when we, should I ask you? I'm going to ask you because I did say to you, I remember clearly. When we're looking at the intuitive approach, and we're looking at the function of a limit that tends to -2, what did we do when we look at the intuitive approach? I could be in my bed sleeping and talking to myself. I didn't have to come to class and talk to myself.
Sir, repeat the question, please.
My question to you is, when we're looking at the intuitive approach, and investigating the limit as it tends to say, for example, -2, what did I do? I looked weird.
We look where the X is, sir.
Yeah, you look where the X is here, but when we're investigating it, what we did. Somebody not studying.
So we look to the left or the right.
Yeah, come on, guys. Remember, I'm building on my information, you know. So we have to look at the right-hand side and we have to look at the left-hand side. So when I'm looking at the function as x tends to -1, I have to look to the right of -1 and I have to look to the left of -1. Remember, I have to look at both right-hand side and left-hand side. Talk truth. You remember now?
Yes, sir.
Yeah, man, I have to look to left-hand side, right-hand side. All right? Now, see yourself. I'm looking to the left and I'm looking to the right. -2 to the raised to the negative is to the left of the function. -2 to the right is to the right of the function. So just like the intuitive approach, when I'm looking at my piecewise functions, I must investigate what is happening to the left and I must investigate what happens to the right. And Sir said to you, when we investigate what happens to the left and the right, and if both are going in the same direction, then we say what? The limit exists, don't it?
Yes, sir.
Yes, sir.
We say that it is of a good behavior since the limit approaches 0.5 in this example here from both the right-hand side and the left-hand side. So it behaves well if it goes to left and right. So it is that we can say, yeah, man, it exists. If the limit goes into opposite directions, then we say that the limit does not exist. But once it goes in the same direction, yes, we say that the limit exists, guys. Anyway, that's it. That's it. I'm going to study. So I'm investigating the left-hand side, the right-hand side. Oh, sir. So you're saying now that when I have the superscript negative is to the left and the superscript positive is to the right? Yes. All right, let us relate these two, the left and right now, to the functions over here. So you notice that this says x less than -2. When it is less than, it goes to which side, left or right?
To the left.
Very good. L for L. Left is L and left is L. L for L, not H-E-L-L, no, because we don't give that part. L as in lavish, right? So left begins with L and less and left and less, right? Less and left begins with L. So when I'm looking to the left, which is this negative up here, so it means that this is the only function that deals with to the left of -2. The only function that deals to the left of -2, right? When I look to the right, watch me. Remember, this function is going to be used how many times? Say 2.
2.
Yeah, man. Because in one instance, it's going to be x is greater than a -2. And then I'm going to use this function again when it is less than -2. So the function that deals with to the right of -2 is going to be this, where x is greater than -2. That's why I'm using this function, 2x minus 1 and x minus 3. All right. Now, what we're doing, what I want you to do in 2 minutes or me, is to use the calculations approach now and substitute your values here and tell me if you agree with this -5 and this -5. 2 minutes, 1 minute as a matter of fact. Are you okay with that now? Are you agreeing that it's -5?
Yes, sir.
Nice. Anywhere in the function I see x, I'm going to put -2. 2 times -2, see right here says -4. -4 minus 1 is -5. And in the second example, -2 minus 3 is -5. So I can conclude that the function is continuous at x equals -2. Remember them asking, determine if the function is continuous. We can tell them, say, yes, the function is now continuous at x equals -2. Why? Because the piece here and the piece here is of a good behavior. Now, see my statement here? I think I should put this statement right here. So, since the limit as x tends to -2 to the left of 2x minus 1, that piece here, is equals to the limit as x tends to -2 to the right of x minus 3, the piece here, comma, then f of x is continuous at x equals -2, and that's my statement. F of x is continuous at x equals -2, right? So I'm making that statement now. This statement is important because I'm asking it to determine if it is continuous. So let me do this piece alone and don't conclude. Now answer the question. If a man is found stealing bananas and you do investigation and you find out him stealing the truth, but you don't convict him, it was a useless effort in doing the investigation. So you have to conclude. I want you to know some things here first, though. I want you to note something here first. To the left means less than. I did say it, but I wrote it. And to the right means greater than. I'm going to stop and think back to the number line. To the left means less than. To the right means greater than. As I said to you, some of the stuff them I'll write down. I'll write down some of the stuff them, but I can't write down everything. So to the left means less than. You notice the L and the L. To the right means greater than. The one that starts with the L, the one that starts with the L. The right R ends with R. The one that started, because we go to the left first, and then we'll go to the right after. The right, the R's end it. Does that make sense to you? Do you think you can use that to remember it all the time?
What, sir? Left mean less than right means more or increase?
Mm-hmm.
Sir, it's like negative and positive, right?
That's exactly what it is.
Right.
Okay, good. And then the second thing that I want to note is that we're going to start at x. It is read x is greater than -2 and x is less than or equal to +2. All right, equals a positive 2. I'm just looking at for emphasis. Just for you to know that we have to speak in definitive terms of the right? Okay, so now we're going to investigate at x equals 2. At x equals 2. All right, let us go back now. At x equals 2, do we consider this equation any at all?
The first one, sir.
Mm-hmm.
2x minus 1.
Yeah, do we consider 2x minus 1 now when we're investigating x equals 2, the limit as x equals 2?
No, sir.
Why?
Because the 2x, the 2 doesn't stand alone, sir, in that equation.
Not
Because
a
it goes
constant.
no, because it is going to -2. I'm not interested in -2 anymore. I'm now interested in +2. So I'm interested in this one because it goes to +2. And I'm interested in this one because the other end of this one, the middle one, goes to +2. This is -2, so I'm not interested in this anymore. So just as I wasn't interested in, just as I wasn't interested in this before because I was dealing with -2, I am not interested in this one anymore because I finished with -2. Get me?
Yes, sir.
Yes, sir.
Sorry, my assistant is asking all this well, and I know why she's asking. Hold on. Oh, she's teaching too. Oh, she has a class now. Oh, since I'm going to say. All right, now, so question. Remember now, we're going to the we're looking at +2 now. Now remember, when we're doing the intuitive approach, when we look at a number, we look to the left and to the right of the number, don't it?
Yes, sir.
And I'm going to tell you why. Let me just confess something to you so that you understand what I'm talking about. The reason I want to hear the feedback, because I know normally we mute our microphones in class, and that's the best way to go, because I know, sometimes our backgrounds are a little bit noisy. Now, I, as a lecturer, will have to make sure that my background is not noisy because my microphone will always be open for the most part. Why I want to hear from you is because I know that you are there when you unmute to speak to me, and that you're not just listening and washing the dishes or cooking a meal or drop asleep. I really want you to respond. So when I hear Dwayne and Laura and Tess and Diana answer me, I want to hear the rest of you answer so that I know that you are there. So I just tell you what it is just now. That's why I want to hear from you. When I hear you answer me, I know you're close by your system and that you're paying attention. All right? I want you, and students, if it is that you're distracted in the business calculus because you're doing all these manner of things, stop it. It is going to come back to haunt you. It is going to come back to haunt you and haunt you in a terrible way. Focus on what is happening. It's when I give you exercises, more if you do them. It's when I tell you, say, don't blink, it means that the Sarah talk board is important. You see how long I take into this question is because I'm teaching you the question. I'm teaching you the question as I go along, teaching you how to answer and explaining what it is that you're doing. I could have come and say, okay, this is what you do and support and move on. No, may I find real life example and show you so that when you see the question, you can interpret the question on your own. All right, so please work with teacher. So let us go back again. So when we're investigating now, x tends to, x is equals to 2. X equals 2, it means I have to look on the left of 2 and the right of 2 because I'm investigating 2. So I have to look to the left and to the right of 2, right? See here? To the left of 2 is 2 to the negative. To the right of 2 is 2 to the positive. So I can write down these two things, but now I need to say which one of the equation goes to the left. Now watch me. Remember, I'm not interested in the negative 2 part here now, So we can cover up this part and just work with the part here. When I read this, I get x is less than or equals to 2. Agreed?
Yes, sir.
Good. So if I say x is less than or equals to 2, it means that x minus 3 is a less than function. See it here, so? X minus 3 is a less than function. Also, then by default, the other one is a right-hand function here, but make we check still. X is greater than, yeah, I'm right. R for R, greater, yeah, it's true. So this one is going to be x minus 1 to the right. See it here, so? X minus 1 to the right. Remember, the superscript tells us if we're to the left, and left means negative, and the superscript tells us that we're to the right, and the right means positive. And all we're going to be doing right about now is substituting into the function to see what it comes out to be. So we're using the intuitive approach for this first piece, and then we're using the calculations approach for the second piece. So guess what? We can't say we're not ever going to use the intuitive approach because we don't must. Watch me. Wherever in the function now I see x, I'm going to put 2, not 2 minus, 2. 2 minus 3 is negative 1. And then 2 minus 1 is positive 2. Blow out. What's certain 2 and 1 on the same number? Very good. So I can now say, since the limit is not equal, then f of x is discontinuous at x equals 2. So it comes back to the point now where the function must be well behaved. Well behaved means that them go to the same number. Well behaved. Me I sit eye to eye with you. You tell the daughter, no, you're not going to that party. You're not going to that party. Mommy, daddy said I can't go to the party. I'm sorry. Daddy said no, you're not going to the party. Mommy, can I go to the party? No, you can't. Daddy, can I go to the party? Yes, you can. But daddy said I can't go to the party. No, mommy and daddy no need to talk because it means that they are discontinuous. They're not agreeing. And if you go to the party and something happen, me tell you say no for me, she go to the party. And if you go to the party and nothing happens, see, why she couldn't go to the party, nothing happens. There is no consensus. All right. So it has to be the same thing going to the same number. And we say that it's continuous. Just like when sir was drawing something, watch my mouse. So a continuous function, watch the screen. A continuous function is something going like that. And I'm not lifting. Don't know how we're going to do this continuous one now. This continuous one is when I'll draw something. Let me just see if I can do this. So continuous function is when I go like that. Continuous. I'm not using my right implement. I just doing that for show now. Discontinuous is when I go so, then I go so, then I come up from here, so I go so. So these now will become my points of discontinuity. My points of discontinuity occurs right here, so the function cannot exist right here, so, and the function cannot exist right here. Right here, so the function exists everywhere. Everywhere the function exists. Oh, then sir, this is like when they talk about the polynomial function, yeah. And this is when they talk about the rational function, yeah. All right, so that's what we talk about. Okay, so let's go now. Let's go, let's go, let's go. Oh, we're done. Are there any questions? Are there any questions?
Not yet, sir.
Not yet, okay. Oh, and incidentally, we have to, at some point in time, know, at some point in time, I have to go and sketch a graph, but I'm not interested in sketching the graphs today. Negative. Matter of fact, I may even move on from sketching the graphs into some other areas where I have quite a bit of this thing here for you today. I may even move into my continuity, my unit 2. So I'm finishing off unit 1. I know I'll finish off unit 1 today. And then I'll look at unit 2, talking about some points of discontinuity. And hopefully I can go through discontinuity and maybe, oh, unit 3 talk about average rate of change. Oh, but unit 2 is short. All right, we're going to do unit 2 today. Continuity. And then no, this one is easy to, average rate of change. Easy something that you just put in our formula here. Once you know if you put in another formula here, you can do any question. So that piece is easy. So if you look on this, you recognize, say, that piece is done. This done, because all of this is average rate of change. Yeah. And that's the end of my so-called document. All right, come. Let's see if we can, how far we can go today. So as you know, what's your, how sir doing thing in teach you, they didn't give you one question to do. But let me show you what I want you to do for me though, is in doing the one question, sir want to make sure that you can look back at what it is that he did before. And that's average rate of change, average rate of change. Yeah. All right, so this is what I just did a while ago. And then I'm going to ask you to do this for me. I'm going to give you about 7 minutes. All right? I'm going to want, do not worry that you have a fraction in there. I saw the teacher them go on and them not give no fraction of the example and then from own them do a fraction. Don't worry about it. Don't worry about it. What I want you to do, don't worry about the sketching of the graph. I'm not interested in that point yet. I want you to look back at what it is that we did here. And here, including my statements, you don't have to put the please note part. This please note is also for explanation purposes. And then I want to see if you can tell me if it is continuous at x equals -4 and x equals 1. All right? Start. I want everybody, you don't know who I'm going to call upon first. And I'm going to come to class and say, who is finished? I'm going to call upon somebody. So I will know whether or not you are there. All right, so I'm looking in the chat and I'm seeing where 2 students are asking for help. Addition to the WhatsApp group. Please assist accordingly. All right, I'll give you 7 minutes. Start, please. I'm stepping away for 2 minutes after the 7.
All right, before you step away, could you just zoom in a little bit, sir?
No, I can't. When I share the screen like that, I can't zoom in. So I'm going to ask if you can just, from your system, if you can just pan in from your system.
All right.
Are you using a computer or a phone tablet?
Using my computer, sir.
Oh Lord. When I put it in the read view like this, I can't zoom in from here. I'm sorry. And if I don't read like that, I can zoom in, but if I don't read like this, you're not going to see the workout that I did before, and I want you to see the workout to guide you. So I apologize. If you were using a tablet, you could just pinch in to expand. All right, I apologize. Obviously.
Not sure. As it so I think I get 1.
Oh, you're still working. All right, never mind. Continue working. I'm right here. Continue working.
No, I'm finished, you know, sir.
Oh, you're
I'm working with 1.
Oh, you got
You're
one.
right here.
Oh, I got to say, I thought you say you got one of the answers, but you got 1 for your answer. That's what you're saying?
Yes, sir.
Okay, all right, cool. All right, let us check to see what is happening here now. So I exit, boy, my youth. Boy, my youth. So he's looking at x tends to -4. Remember, this function is x tends to +1. We're not interested in +1 because we're looking at -4 first. Matter of fact, this side of it, we're not looking at either x less than or equals to 1. We're not looking at no 1. We're looking at x is greater than -4, and we're looking at x less than 4. So we're going to use these two functions, a half x plus 3 and 2x plus 9. See here? Half x plus 3 and 2x plus 9. Anywhere in the function you see x equal to 4, -4. So this becomes -2 plus 3 is +1. Very good. And -4 times 2 is going to be -8 plus 9 is going to be +1. So since the limits are equal, then f of x is continuous at x equals 4. F of x is going to be continuous at x equals 4. All right, very important. What did you get now for x equals x tending to 1? Is it continuous or discontinuous?
Yes, sir.
Discontinuous? No, man, discontinuous. Because remember, you know, the limit of a constant is the constant itself. So the limit of a constant is the constant itself. Always remember that. So when I look at this question, you work it out, Andy?
I got the 11 right for the.
For this part up here, sir?
Okay. It's just that alone I was supposed to work. I wasn't supposed to touch the half x plus 3.
No, man. So if you work out this part here, the 2x plus 9 and got the 11, that's very good.
Right.
But you also no need to work this part here. But remember now, this is a constant. So when you find the limit of this constant, is going to be the constant itself. So that one is also going to be 11. So both of them are also equal. So therefore, it's going to be continuous at x equal 1 also. That's a continuous function. Are there any questions? Is there somebody in the class that don't fully get up with you? Speak no.
Yes, sir. Just run over again, sir. The last part, the second part.
All right. So you understand up to here, this piece, the top piece here, to say that all right, x tends to -1 now. So we're looking at -1. We can't look at this function here, the half x plus 3, because that goes to -4. All right. We want the function that it goes to +1. We want the function that goes to +1. All right. So it must be we're not even looking at this x greater than -4. We're looking at the less than 1 and greater than 1. So these are the two functions that come into question now, right? The 2x plus 9 will have to be x tending to 1 to the left. Why to the left? Because this is less than. And this one is going to be to the right because it's greater than. So this is where we are. To the left, see here, 1 to the negative is this function, and 1 positive is this function. Now, where x is equals to 1, 2 times 1 is 2 plus 9 is 11. But remember, the limit of a constant is a constant itself. So it no matter where this will go down, you're saying, no, here it go. The mere fact that you have a constant here, this number is going to be the same as this number here. The limit of a constant is a constant itself. And then you make your statement. And that's it. Clearer?
Yes, sir.
Try that for me, please. Remember, don't worry about sketching the graph. Not just yet. We want to get this piece up and out before we do the other part. So start that for me, please. I'm not going to change my screen because you guys would have worked the second one. So just do that piece for me. You should be good to go. And remember now, I want you all to participate in the activity now. And I want you to just sit down and passively just wait until the answers are done and then you say, yes, sir, I understand. I want you to be a part of what is happening. Finish, guys? This one is much easier. So this one just have one calculation. What did you get? Is it continuous or is it discontinuous?
Discontinuous, you know.
Is it continuous? Everybody agrees with him?
Yes, sir.
Yes, sir.
You got -3 and 0?
Yes.
Yes, sir.
Yes, sir.
Well, wicked. All right. About understand about it? All right. Because no, I'm gonna get that one here now. I'm gone back to 3. Too easy for me, so I'm gone back to 3. Try that. Maggie, less time, you know, kind of get wicked on something now. Very nice. Proud of you. How is it?
Sir,
Mm.
I think it's continuous. When I
Weird.
plug in information, I get +1 for the answer.
But let me just, all right, hold on first. I'm sitting right here with my mic muted, guys. So when you finish, just say something so I can just unmute. Because I'm giving you enough time, but if you finish before, just say something. Because I'm right here. I'm not away from the system. When I'm getting up, I will let you know. 2, if you tell me that it's continuous, you can tell me where it is continuous. And if it's discontinuous, you can tell me where. So start again and tell me where it is discontinuous. Is it x equal -2 or x equals 2?
X equal -2.
So it's discontinuous at x equals -2.
No, continuous at -2. But
It's
I
continuous.
also
Go ahead.
yeah, but I also believe that it is also continuous at +2 as well.
Okay. All right, no problem. All right. I hear you, Dwayne. Damien, sorry. Thank you very much. And we're gonna see if anybody agrees with you. Dwayne is getting it to be continuous at x equals 2 and x equals -2. Is there anybody else that is agreeing or this?
Doing that x minus 2 is discontinuous and x and 2 is continuous.
Right, that's what he said. Right, that's right. So Dwayne, do you agree with Damien?
You're mixing up the two names, you know. I think Damien is saying that x minus 2 is continuous.
Oh, so Damien is saying that both of them are continuous. But you doing saying that x minus 2 is discontinuous?
Discontinuous, yes.
Okay,
yes.
got you. Norman, what are you saying?
I was saying that x minus 2 is discontinuous.
And what about x equals 2?
X continuous.
Go ahead.
I was going to say why.
Oh yeah, go ahead.
At x minus 2, the figures that you'll get is +1 and -9. And the figures at x plus x equal +2, each of them is -1.
All right, thank you very much, Sir Norman. The man them come out strong. Andrew Han, I mean, you just have to unmute no Andrew Han and answer because the other you them answer. So your turn now.
My turn, sir. Sir, I get a discontinuous. X being discontinuous at 2 positive.
At +2?
Yeah.
What about -2? What you got it to be?
-2, I got x being continuous.
Okay, so you got it the other way around. Fair enough, that's fine. I'm interested in the efforts now. All right. The man them answer. Calling it cannot see a microphone displayed for you at all. You know, Diana, what say you?
Sir, I got discontinuous at -2 and continuous at +2.
All right, so you are agreeing with everybody away from Damien and Andrew Han. Okay. Laura, what say you?
All right, sir, at x equal -2, I have discontinuous. And my answers are 1 and -1, sir. And at x equal 2, I have continuous, and the answers are -1 and -1.
All right, Tess, what you say? I hear Laura. What you say, Tess?
I have the same thing Larry has. Discontinuous for -1.
-2. All right. Appreciate it, Honey Bunches. Shop, you come class later, don't even say, oh, this sir, come, your turn. Shakir, your answer, please. All right, so she's still sleeping. For the grand reveal, Rockstone, you know, so what keep. I never did it. That's not good. Oh my goodness. And I'm sitting right here now. Oh, Lordy, Lordy, Lordy. I'm sitting right here. All right. I will run through it pretty quickly and see if I get the same answer. I thought I had an answer. SOLUTION. I thought I had it. All right, so the solution slips me. X equals -2 and x equals -2. And x equals -2. Yeah, x equals -2. And x equals -2. And x equals -2. And x equals -2. Hold on again. And x equals -2. Where am I? I family better second right here. So I'm never realized. -2 less than is 3x plus 7. 3x plus 7. That's -2. 2. Which one? That one is x squared minus 5. Interesting. I agree with those who said that x minus 2 is continuous, you know. Did anybody get that what I got? 3x plus 7.
Repeat that, sir.
I'm checking my function again. I'm getting to be continuous. 3x plus 7, x squared minus 5. 3 2 is -6 plus 1 is 9. Yeah. 2 2 is 4, 4 minus. Yeah, man, I get. No, anybody got this?
But shouldn't that be 1, sir? Because the 7 is positive.
Yeah, man, that's what I meant.
-6.
Oh, this piece here.
That should be -1.
No. It's supposed to be a +1. I just put that there to see if you're paying attention. 2 2 squared is negative. Okay, so it's supposed to be discontinuous.
Yeah.
So, sir, when it's positive, is it discontinuous when it is positive or when it is negative?
Discontinuous when them not favor. When them not favor each other, them
Oh,
discontinuous.
yeah, when it's two different sides.
Yeah. When them not favor, you know what I did a while ago? I copied see, and I'm doing the same thing again. I copied the information and never changed one of them. So when them not favor like the one you one and the one you -1, when them not favor, them discontinuous. Agreed? And it's not p of x, this one is f of x. And it's not x equals 1, it's x equals -2. All agreed so far? Most of you did say that to me. Let us check now to see continuity now at x equals positive 2. I have that one already. Positive 2 would be the same as function x squared. Same as function x squared minus 5. What is the other function on 5x minus 6x? All agreed? Now, Damien, I want you to look back at what it is that you said to me. Let me reduce this somewhat. Reduce over 10. All right, Damien, look back at what it is that I have on screen right here. Congratulations to those of you who got the first one to be discontinuous and the second one to be continuous. Look back, Damien, and tell me if you agree now, or is there something that you want me to explain for you to you. Shaquille, Damien, are you there?
Okay, I've seen very wrong, sir.
It's
Yes, sir.
very
I've seen
wrong.
where-
All right, cool.
Yes, sir.
Is there anybody else in the class that did something else and now seeing where it is that you can make your corrections? All right. I need to just make sure that okay. All right, there goes another one. I have not done that solution either, but start for me, please. Very good. Come to in. I depend on you now to get this one quick with time. This one is easier. It's only 2. Do you recognize when I have only 2? It's just one time we do it, and when we have 3, we do it how many times? 2 times. Can we have one function and text for continuity in this way as a piecewise?
No, sir.
All right, good job. Great answer. No, you can't, because you can't do a piecewise without one. So I can't compare one something. I have to compare 2 or more. All right, so do this one quick time. Quick time. I don't know if you do something. Quick time. 1, 2, 3, quick time.
It continues, sir, at every 5.
When I said quick, I never expect to be that quick, but okay, thanks for the information, Shaq. No problem, honey. I pray that everything will be fine. Mr. McCanty said, "Am I learning on? You want doing a learn? So quick can do this up? What's your talk about, man? You not teach me good, man?
Sir, getting the 5, sir.
Yeah, man. I thought the answer I put in 1 is a 6 minus and a 5. 2 times 1 or 2. 2 plus 3. Sir, continuous at x equals 5. I mean, continuous at x equals 1, and the answer is going to be 5. Yeah. All right. So because teacher don't have that answer either, let teacher just continuous, just copy this piece here, so drop that here, so paste that down here, so x equals 1 again, copy it right here, so put right here, so paste right here, so and then again come here and say to the 1.
Sir, I have a question.
Sure, go right ahead.
The one that you did. Where it says x squared minus 5. Notice when you're doing the workout for that, it became minus 3, is it?
Which one? X squared minus 5? No, man. X squared minus 5. X squared, x is negative 2, 4 is negative 2 squares is positive 4. It's a put 4 squares.
I mix up something. Oh.
Well, and thank you for looking at that. To look back and see that I typed something wrong. So 2 squares is 4, and 4 minus 5 is equal to negative 1. But this one here, no. No, redo. Paste that this one to the. This is 6 minus 6, and this is 2x plus 3. All right. Tell me if you agree. Do I have everything correct right here? Talk to me.
Yes, sir.
All right. So okay, so I have the answer for this one. All right. Our sir go down to x squared minus 1 over x minus 1. I want to, sir, man. All right, yeah. I don't know what the exam will give you here. So I'm just trying to get creative in what it is that I'm doing. So anything that they give you should be able to do it. So this one is a little bit more, so I give you maybe 5 minutes. I don't know if you do it in 5 minutes. Start it. Importantly, very good. I am proud of every one of you in the class. You are learning. Those of you who know within yourself that you are struggling a little bit, you're not asked the question if you're understanding. Please say something to me. We meet once a week. None of you should leave the class any given Saturday without understanding what is being done. Please. Very good. Keep up the good work.
So, sir,
Yeah.
all right. We throw math another one, yeah. Discontinuous at x equal 1, continuous at x equal 2.
Continuous at x equal 1. And discontinuous is your continuous at x equal 2. Which one?
Continuous at
Oh,
x
continuous at
equal.
both. All right, continuous at both. Okay,
Huh?
fine. No, you're saying that it's continuous
No,
at
I said
both.
no, I said discontinuous at x equal 1.
Okay, sorry. But continuous at x equal 2.
Yeah.
All right, cool. All right, hold on to that. Guys, Norman is out of the blocks. Quick time. Let us see if the rest of you will catch up with him.
Agreed, sir. I agree with Norman.
You agree with Norman? Yeah. Maybe you went to that other school on that other road too, but anyhow. Let us see. Come on, guys. Easy peasy. Incidentally, everything that we've done so far will be on your mid-semester, including this topic. So make sure, say, you catch it. When is the mid-semester, sir? I don't know yet, but soon. Norman said discontinuous, continuous, Do we not raise? And that raise. Who next? I'm here. Andrew, Colin, Nick, Damian, Diana, Laura, Lee, Shaquille. Well, Tess.
So I'm in agreement.
In agreement, okay. Does anybody else?
Yes, sir. Discontinuous at 1 and continuous at 2.
I get continuous at both. I may be wrong. Look at what I have. Let me reduce it. Look at what I have. And tell me where I may have gone. When I may have gone wrong. Look at it and tell me where I may have gone wrong.
Ah,
So if
The fraction part.
all right,
Yes, sir.
mysterious diffraction.
Mhm.
all right,
And that
now,
wonder the fraction,
uh,
because when you split it, one over negative, one over positive.
all right. So I know you weren't here, Norman, when we looked at the indeterminate form. Is the first piece indeterminate? Yes or no? The x squared minus 1 over x minus 1 as it tends to 1, is it indeterminate?
Yes, sir.
Yes, we have to do something. So I can see why I want to get that. But look at it again now. Take 2 more. By the way, x equal 2 is okay with everybody done.
Yes,
Yes.
sir.
Yes, sir.
A couple of minutes and look at one for me.
Oh, I know I forget that one.
Don't worry about it, you know. Middle way for finding you. So we're all on the same page now. Matter of fact, let me ask you, Norman, did you get the second part of the limit here to go to 2 right here, so?
Yes, I did.
All right, good. So I know where the problem is. The problem here is this one. This is indeterminate. The problem is in indeterminate. All right, continue, please. Always stay. Always stay. We're good? Everybody seen this piece up here? The indeterminate form?
Yeah.
All right. I don't have any other question. I just wrote on the 5. I don't have any other question. I need your honest feedback. How are you feeling? I gave you enough time a while ago just to look back at this stuff. How are you feeling? You feeling comfortable with the topic, or you want to run another quick exam? Tell me how you feel. I need to know. Guys, let me talk to you, man.
For me, I would say I'm a bit okay. I just need to do some practice.
Thanks for your honesty. How the rest of you stay? See, like I'm talking to all of you.
Because you know, we just feel like we need a conk.
And I said to you, you don't have to ask for that more than once. Let me generate another question.
All right, question. All right, say the formula that was there before for the P of x, instead of it being x squared minus 1 over x minus 1, if it was x cubed, how do you work it?
Same difference. Same difference, but I won't give that cube though in that case, but same difference. Same difference. Sorry. So I'm actually generating a question. Let me just give me 2 minutes. I'm almost finished. Oopsie daisy. All right, I'm finishing the question. Just like I do my coding. All right, that's better. All right, oopsie is supposed to be -4. And this one's supposed to be. All right, that was a quick. Let's check something quickly. Okay, run with it. Any luck so far?
Still working, sir.
All right, thank you.
May I look to see if I make no mistake?
Yeah, true. Come, me no want to get two counts.
I get discontinuous at both.
And will that be your final answer? I guess not. Is that your final answer?
Come on, I will have another one. Continuous at both.
So you hold on for that. So you're discontinuous at both. Andrahan, Dwayne, Damian, the Stalls, Mitchell. What is it?
Work along the same line, discontinuous at both.
Got you. Andrahan, come out of the bed, man. Me not hear from you this week. That's unlike you for the last 2 weeks. Something is happening. Tess, what you say?
This continues.
Where funny bunches are things.
For both.
For both? Sound so sure, you know.
I'm still going back over it, sir.
Oh, you're going back over it? Oh. All right, now give it 2 more minutes. 2 dege minutes more. I love it. All right, final answer. What's the final answer?
So can I change the first one to continuous?
Okay, you're changing the answer. All right, no problem. As I said before, well, as you would have seen, I only just write the question. So, we're going to work the question X is -4. Do Nobody agree with that? We talk to me in a moment. Am I muted? No, I'm not. So, you guys are hearing me.
Isn't that supposed to be -4 minus -4 plus 4?
Is it x plus? Is no, it's x minus 1, you know.
Oh, the underneath is x plus 4.
Underneath is x plus 4. Right? Oh, yeah. You see when you copy and paste, that's what happens. It's supposed to be x plus 4 and then x minus 4. But my answer is still right because I had the same x minus 4 right here. But you're correct. You're correct. So -4 is going to be -4 is -8. And this x minus 1 is -4 minus 1 is -5. All agree with this piece here? Yes, no?
Sir.
Okay. So x equals -4. And then now, x equals 0. X equals 0. I'm going to have x minus 1 and x. Okay with that? Guys, please just talk to me now, man. Is that a yes or a no?
Yes, sir.
No, not like it. So, none of the answers coincided, so this continues at both ends. And I thought about it when tests says to me that, she just need a little bit more practice. I say, let me find two pieces that are discontinuous at both ends. Because I don't want to go into the exam and things say, them give you the question, say it have to be continuous. And that's why I was laughing when Norman came out and said, yes, sir, we get it. And then he said, hold on, let me double check for you. And then I think it was Tess who came out and said, or Laura, one of the two, came out and said something. And I figured to myself that, because they're getting both of them to be discontinuous and thinks that something is wrong. Yes, they can give you both of them being discontinuous, and can give both of them being continuous, and can give one continuous and one discontinuous. You don't know what it is. Just work it. But irrespective of how you work it, just double check your answer to make sure that you are there. All right? Okay. So we're finished with that. Our unit 2. Yeah. There is a statement there for the conditions for continuity. So having done this, how do we know what are the conditions for continuity? When we say that a function is continuous, what do we mean? I am now defining continuity. And in the definition of continuity has 3 conditions. What are the conditions, sir? That f of a exists, meaning say, I can find f of something. It means say, my function has a variable there that I can go ahead and substitute in order to evaluate f of a. So f of a must exist. Now watch me, and watch me carefully. The limit as x tends to a to the right must be equal to the limit as x tends to a to the left. That this meaning of? See the statement, and that's why I keep writing the statement every time. So that you see, right as I said, the limit as x tends to 0 to the left is not equal to the limit as x tends to 0 to the right. Therefore, the function is discontinuous. But if we're looking at a continuous function, conditions for continuity, it means that the limit as x tends to 2 to the left is equal to the limit as x tends to 2 to the right. Then the function is continuous. For continuity, f of a must exist. See, Chester? Come on now. We must be able to find f of a. So f of a exists. The limit as x tends to a to the left and to the right must be equal. Then, which is going to be equals to x tends to a of f of x exists. So if we can do this, that means if this exists and them two here exist, then we can say the limit as x tends to a of f of x exists. Sir, what does this mean? All right, good question. You notice I say at x equal, what is wrong with me tonight today? You notice I say at x equals 0, and then we investigate into the left and then to the right. If when I investigate to the left and investigate to the right and them exist because the two of them are the same, then I can say that the function of f of 0 exists as x tends to 0 exists. See here? If the limit to the right and the limit to the left are equal, then I can say the function as x tends to a, not the right and the left again, because we know the right and the left equals, we can just say the limit of x tends to a of f of x exists, right? This have to exist first before we can find out this and this. This must exist. F of a must exist first before we can find out this piece and this piece. If these two pieces are not equal, then we say that it is not continuous. Done. But if these two pieces are equal, then we can say the limit as x tends to a, not to the right or left. We can now make a general statement to the a that f of x exists, this. And then the last piece now is that f of a must be equals to this. F as x tends to a of that. So the two of them must equal. All right? So those are the three conditions for continuity. Press pause. There are times of going to the exam for multiple choice question. Item 42. So that's how much questions I get? No, let me just pull out something into the back. Item 42 refer to the information given below. 1, f of a exists. 2, the limit as x tends to the right of a equals the limit as x to the left of a, which is equal to rotated. 3, f of a is equal to the limit as x tends to a of that. Which one? For continuity, for the conditions of continuity, which of the following is correct? 1 only, 2 only, or 2 and 3 only, 1 and 3 only, all of the above. Your answer will have to be all of the above. But you have to know what it is, because sometimes they can mix it up. Right? Sometimes it can mix it up. So you just have to do what it is that you need to do to let them know that you know what the function is, what it means to be continuous. All right? Any questions? Because the other exercise for the remainder of the class is pretty easy. You know? And I think this will come to the end of my unit 2. Unit 2 is pretty short. Let me see if I can just finish unit 2 and then touch on unit 3, and then we'll just finish off unit 3 come next week, God's willing. All right, so it says find the values of of x for which the function is discontinuous or undefined. All right, so another term for discontinuity is being undefined. So if the function is undefined, it means that it's discontinuous. All right, and I'll explain to you exactly what I mean. Let us go to the solution. This one I'm just going to work with the solution. No, I'm not going to work the solution. I'm going to tell you what it is that we're doing, and then you're going to look at the solution and see if you can figure out what is happening. So they give you a function f of x is equal to 1 over x squared plus 9x plus 20. And they ask you to tell you where it is that it is determine if find the values of x for which a function is discontinuous. Remember what I tell you? Once you have a rational function is a function that has a numerator and a denominator. It's a fraction. Once you have a fraction, you will have a point or points of discontinuity. You'll have a point, or you may have points of discontinuity. All right? Now the point or points of discontinuity occur when the denominator is equal to 0. The points or point of discontinuity occur when the denominator is equal to 0. So in this case, all I'm going to do is to set the denominator equal to 0. That is, I'm going to let, see, the function is undefined. When the denominator is equal to 0, every single time that happens. Not only yesterday, nor today, nor tomorrow, but every single time. Therefore, I'm going to let the denominator be equal to 0. So we're going to factorize up to the value or values. So I'm going to factorize. I'm going to be multiplying the coefficient of x squared by the constant. I think we went through this before. What? Just refresh your memory. I'm multiplying the coefficient of x squared by the constant. The coefficient of x squared is a number in front of x squared. The constant is that term that stands alone. No variable. So I multiply the coefficient of x squared by the constant. So 1 times 20 is 20. I need two numbers. And multiply together will give me 20. But when added will give me the middle number, which is 9. And I'm trying to find two sets of numbers. When I multiply together, it will give me 20. And when I add up the two numbers, it will get 9. Bam, 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 bam. 5 times 4. So 5 times 4 is equal to 20. And I add 5 to 4, I get 9. Very cool. Those are the only two numbers in the world that will come out to be that. Only two numbers. So 5 times 4 is 20, and 5 plus 4 is equal to 9. So I'm going to be breaking up that 9 into 5 and 4. So I'm going to have x squared plus 5x plus 4x equals 0. Then, sir, what if I write x squared plus 4x plus 5x equals 0? Is it the same thing, sir? Absolutely. 1 plus 2 is 3, and 2 plus 1 is 3. Addition is commutative, so it doesn't matter which one I write first. It really doesn't. You get the same answer. And then what I'm going to do next is to group. I'm going to group in. I'll put in 2 in one bracket, leave out the middle sign every time, and 2 in the other bracket. Then I say what is common here, that is common there. What is common to one, that is common to the other. What is common here, that is common here is an x. It's an x. So I'm going to take out that x. What is going to be left is my x plus 5. What is going to be left is my x plus 5. X times x is x squared, x plus 5 is 5x. What is common to 4x and 20? 4 is common. So take it out. What is left? X plus 5. Notice whatever is common in the parentheses here must be the same thing that is common here. So when I factor out the x plus 5 because it's common, I'm going to have x plus 4 is left. So that is equal to 0. Now either x plus 4 or x plus 5 is going to be equal to 0. One of them two are equal to 0. That one or that one. And it's going to imply that if x plus 4 is equal to 0, that means x is equal to minus 4. And it's also going to imply that x is equal to negative 5. All right? Question finish it. Oh yeah, question finish. So it says find the values of x for which that is discontinuous. So this function up top can't take when x equals negative 4, and it can't take it when x equals negative 5. Them two numbers that it can't take. It takes every other number over the real number system away from negative 4 and negative 5. When it reaches negative 4 and negative 5, it becomes discontinuous. Question. Do you have any for me? All right. So since there is none, I am going to be posting example 2. So it is that I will help you to work through example 2 in a non-speaking sort of way. And you are going to be looking at that for me. And then I'm going to put 1 or 2 on the board for you to do. So we can just finish up that. It's not difficult. That's all that there is to it. That's all that there is to it. So I can just briefly talk to you about the average rate of change. So I'm going to give you 5 minutes to go through, especially the factorization. I'm going to give you 5 minutes to go through the factorization. And then I give you 1 to do on your own. And then we'll look at the average rate of change. There's nothing more to this. I promise you. I promise you. Go for me, please. All I'm asking you to do is to read through this. Read through and just make sure you understand the whole factorization process. I'm now taking your questions. Are there any questions for me?
No, sir, I'm good.
All right, cool. Any other? I'm not gonna kill the issue, and I'm not gonna call it everybody by name.
Following, sir.
Great. There goes this one here now. I'm not gonna post the answer yet. I want you to try that one on your own. When you do that one, I can send some for homework for you to do and get some practice. Then I'm going to just touch on average rate of change and call it an afternoon or early morning. Quickly, I'm giving you 5 minutes. Very nice. Hold on. I'm going to change something, and there's a reason I'm going to change it. I don't want to give you a negative one just yet, and I recognize that this one contains something which is negative. But there's a reason for that, not that it's not work, but example 3. That's a question. Don't worry about what I have there as a solution. That is going to be incorrect. But 1 over x squared minus 7x plus 12. But then again, no. Hold on. Let me keep that one as that one. I did say that I didn't want to give you a negative one, and I end up putting a negative one there. So hold on to that one. Say some of the questions I'm going to give you now. James, so this one 3. That one should be fine. That one should be fine. Go ahead, please. Obviously.
It implies that x is equal to -2 or x equal -1.
Good job. Very good. You said -2, right?
Yes, sir.
Very nice. All right. Very nice. I won't touch the average rate of change because that's unit 3. So technically we've completed units 1 and 2. Completed units 1 and 2. I'm proud of you. Let me just use the remaining 3 minutes and just talk to you about something. I started sending out you'd have seen me on Sunday send out the notes for the last class, and I'll do the same for this class. I was doing the
Yes, sir. I'd appreciate that very much.
Yeah, man. And I was in the process now of sending the recordings, and my internet just decided to move very slowly. And then now I really got caught up in the course of the week. I have some very long classes. I only thought about my day to the latter part of the week. Thursday, I teach up until 10 o'clock. Friday, I teach up until 9 o'clock. And I get up Saturday morning for 8 o'clock to teach. So if I don't get anything done up by Sunday, Monday, Tuesday, Wednesday, it becomes very difficult for me to do that because trust me, those 3 back-to-back classes, and I'm not complaining. I mean, I really enjoy what I do. You know, it becomes difficult. So what I promised to do for you is the recording for the last 2, and I don't get the recordings immediately after. I have to wait until the recordings are sent to me, that are generated, that are sent to me. But I should have the recordings for the last 2 classes. So I'm going to, my commitment for this weekend, this is send the recordings to you. Hopefully that this one becomes available by tomorrow when I'm sending them out. And again, I'm going to send out these notes that I used tonight, forgive me, this morning. Plus, I'm going to send some do know questions, so at least you can have some questions to practice on your own. Now, with that said, me no want nobody sit down and have my notes like when you're cute with it. I want you guys to be working and working well. And the final thing is that you are all on Edifosol. Those who came, who were here with us. I know there are 2 students who joined us today. I can put them on, not a problem. But I also want you to be going through your Edifosol and just going through the things that we've already covered. Time is of the essence. I don't see, unless there is a breakout of the coronavirus, you know, I don't see them extending this semester. So I'm seeing within the next 2.5 months, you guys are going to be writing your final exam face to face. Please start working and working now. Those are my few words in Jesus' name. Are there any comments before we say our goodbyes?
As a result, Educosoft, it has been set up for us?
No, yeah. Did I not? Hold on. I'm teaching several codes. Let me make sure that I'm not mixing up with my. Let me just double check something, please. And I'm hoping that I'm not mistaken. Forgive me.
Sir, about when are we going to get the coursework?
I have no clue, but it's ready though. I know last weekend the team sat down and wrote it and submitted it. So I know it's ready. That much I can tell you.
Okay.
No. Do me a favor. I want each of you for me. It's not there. I want each of you for me to drop your. I want each of you to drop your email address. Oh, that's another thing I need to talk about very quickly. What I want you guys to do for me is, you know, sometimes you guys just put it's there. It's there, but I don't have any students yet. That's a problem. All right, so the section was created, but I don't put you guys in there yet. All right. I know sometimes you know having a name like on a telephone number and God bless. You know, towards the end, when I'm trying to find some students in the class, I don't know who is God bless. So I don't know if it is that I can, you know, put your name somewhat. So when we look into the WhatsApp group, I can be able to identify the students that I'm speaking with. There are times I may need to speak to specific students. So I'm going to ask that you just help me out in this regard. Drop your email addresses in the WhatsApp group for me, please, so that I can noise you and then I set up the edit stuff in a few. All right? I don't want to keep the other class because it's now 2 minutes past. Do that for me and we'll set it up for you later. All right?
All right, sir. Hope to receive the information you promised, and we'll certainly drop the email in the WhatsApp group.
All right. That's all.
All right.